Today's flip video is about compound inequalities. Compound inequalities fall into two categories. The first one is called an intersection. And if you think about that word, it means exactly what it says, where two things come together. Think about an intersection of a road. What happens is where the corner is going to be at. The other one is called a union. What comes to my mind for union is a wedding. That's bringing two big families together into one place. Mathematically, what it looks like, I'm going to use a Venn diagram to kind of introduce it to you, something that you can put into your notes pretty quickly, pretty easily. When I think about an intersection, I just said a second ago, is where two places come together. So in my Venn diagram here, an intersection happens right here. What's special about that circle point right there? You've seen Venn diagrams, you've designed Venn diagrams, you've put numbers into Venn diagrams. What that piece right there is, this is what the two circles share. That's where they share. When I look at a union with a Venn diagram, what I'm going to do is I'm going to say I need all of this stuff right here on the left-hand side. I need all this stuff right here on the right-hand side. And what's getting filled in? Everything. When I think about a union, that's exactly what it means. Everything is possible. So, as I'm thinking about these two concepts and I'm looking at them, I'm trying to figure out what's going on with them, there's a pretty big difference between the two of them. An intersection is where two places come together and you're only looking at the parts that are shared. Where a union, you're looking at everything possible. So it doesn't matter if it's in pink, it doesn't matter if it's in yellow, anything is possible. When I look at intersection, I think this is pretty restricted. Versus a union where pretty much everything is possible, anything goes. So as we look and change this into a math concept, what we're really looking at is we're looking, especially in this section we're working on right now, it's called compound inequalities. When I think of an intersection, if I have x is greater than 5 and x is less than 15, when I go on to my number line, here's where 5 is located, here's where 15 is located, I have to make those two concepts come together and figure out what's being shared. So from the 5, we know we've got an open circle, greater than takes us to the right. From the 15, we've got an open circle, the less than takes us to the left. So if I'm looking for the shared piece, if I'm looking for the intersection, what I get for a final solution sits right here in the middle, right there between the 5 and the 15. Those are the only numbers that share. If I go above the 15, that's 16, 17, 18, 19, that'll work with the x is greater than 5, won't work with the x is less than 15. If I go to the left-hand side, if I look at 4, 3, 2, 1, it'll work with the less than 15, but it won't work with the greater than 5. So I need to make sure both pieces work at the same time. The other thing that I wanted to point out really quick, when we're talking about an intersection, we're talking about the word and. Both things have to be true. It has to be greater than 5, and it has to be less than 15. You notice on the graph that I did two specific colors. I did the yellow for the greater than, I did the purple for the less than, and then in the middle of the number line I put it all together to show the endpoint and to show exactly what's being shared. If I look at an example of a union mathematically with compound inequalities, what you're going to notice is a big difference in words. Let's do x is less than negative 5, or x is greater than 2. So onto my number line, here's where negative 5 is at, here's where 2 is at. I'm not going to switch colors this time because I remember anything goes here. So I've got an open circle going less than negative 5. I've got an open circle going bigger. What I see is what I get, anything goes. That's the solution right there directly on the number line. The difference between the two, if I look at an and, I have to look at individual pieces coming together. Individual pieces coming together. Whereas I compare it to the or, what you see is what you get. The other thing I'll point out is that I don't think I did it yet. This is an or. A union is an or. Intersection and union or. You may also see another symbol. For the union, it's pretty easy. It's a U. For an intersection, it's an upside down U. This is our introduction. If you look at the next video about compound inequalities, I'll show you a few more examples.